Hello and welcome to the video on Chapter 6, VLAN. VLAN stands for Virtual Local Area Network. That is the focus of all of Chapter 6. So the idea behind a VLAN, I'm just going to jump to the next slide while I explain essentially what they're saying in this slide and why we use it, because the next slide has a bit of a picture. So if we're looking at, I'm looking for this one. So if we're looking at a virtual local area network, the idea is that normally routers separate networks. We call that a layer 3 level. We could use a layer 3 switch. We don't use them in these courses, but at the level 3 or layer 3 switch or router, that's where we separate networks. And that allows us to reduce the broadcast domain. So we discussed broadcast domain in previous classes. Broadcast domains are usually separated by routers, and each network has its own broadcast domain, which means when you send a broadcast on a network, it goes to every device on that network. Now, routers can separate broadcast domains, but at the same time, we don't want to be plugging every single device we have into a router. That's the purpose of a level 2 switch, really. We want to use level 2 intermediary devices to make that connection. So if we look at this network, for example, it has one router which could connect it to other networks, fair enough, but then it has switches that allow it to separate the different floors. So each floor has a switch that they plug the devices in. But maybe on each floor, there's a couple IT people, and we want those IT people to be on the same network as each other so we can either prefer their traffic or give them different permissions or give them access to different things. Maybe there's HR on each floor, and we want to be able to give them special permissions, or we realize that the data they have access to might need to be secured from other areas of the office. So we want to put them all on the same network. And then we also have sales on every floor. And again, we want to keep sales all together and be able to give them permissions together, but we don't want to have to, or we want to have them all on the same network, but we don't want to have them all plugged into the same device. This is where virtual local area network comes in quite handy. So when we want to create a virtual local area network group, essentially what we're doing is we're saying these computers, even though they're not plugged into the same devices, are going to be on the same local area network. And even though these three networks, VLAN 2, VLAN 3, and VLAN 4, are only connected via switches, the broadcast domain of the broadcast domain of VLAN 2 is only to these devices, the broadcast domain of VLAN 3 is only to these devices, and the broadcast domain of VLAN 4 is only to these devices. So that can be quite handy in allowing us to separate our network traffic, reduce those broadcast domains, which can help us reduce our collisions, and help us to maintain our traffic in specific ways. Now, that being said, because these are separate network addresses, you'll notice that these are their network addresses down at the bottom here, they do need to be, the traffic between these VLANs does need to be routed through a layer 3 device. So quite often that will be a router. It could also be a layer 3 switch. However, in this course, again, we don't really work heavily with layer 3 switches, although there is often reference made to them. So if we want to route something from something on VLAN 2 to something on VLAN 3, even though they're in the same switch, they do need to go through a layer 3 device because they are separate network addresses. And the real purpose of a router is to route traffic. It's to send traffic where it's supposed to go, or to get traffic and direct it to where it's supposed to go. It's all about the routing of traffic. It's not a managing different groups thing. It's a network routing traffic thing. So we still need that device in order to route traffic, but what we can do is we can split up the devices on a single switch to multiple networks. And then amongst multiple switches, we can have our networks communicate within each other. So if that sounds a little bit complex, it is a bit, but the Cisco command line does a lot of it for us. We just need to know how to configure it, set it up, and have a bit of an understanding of how we would design for it or configure for it. Okay, so usually when we're configuring networks, we want to break up on a few different things. We might want to break up on physical location. North Campus might have their own network. South Campus might have their own network. We might want to break up based on building, based on floor. We might also usually want to break up based on the traffic. So it could be sales, HR, and IT. It could be teachers have a network, students have a network, and IT has a network. You'll find often IT or the network administrators have their own network that they can prioritize traffic to in case of issues. So they can maybe shut down network traffic to other people and keep theirs up so they can investigate. We also might want to separate by the type of traffic we're sending. So for example, if you're sending VoIP traffic or you have your phones running over voice over internet protocol, you might want to give some preference and make those the high priority network, your phone network, so that you don't have people dropping in and out of calls. If there's a couple second delay on an email, it's annoying, but it's fine. If there's a couple second delay in a phone call, that can be super annoying. So that can be the other place in which we're doing this. So the whole point of this is this idea of, well, on just switches, we create multiple networks, and how can they communicate with each other? So how do we set it up so the switches know, okay, if I'm sending a broadcast, it goes through all 3 of these switches, but only to these devices. And that's the fundamentals of setting up a VLAN, essentially. Okay, so it's a logical network setup, not a physical one, but we are setting it up and configuring it within the switches themselves. So we can create multiple subnets on a switch network without the use of multiple VLANs. However, they're all under the same layer 2 broadcast domain. This means that, okay, so the big problem, I'm just reading through this section here, I'll highlight it for you guys. The big problem that we're looking at is ARP requests. Whenever a switch sends an ARP request, it sends it to every device that's in the network, which means if you have 100 devices in your network, every ARP request is going to go to that. If your networking team is monitoring network traffic and regularly checking the location of things, those requests are going to go to everything, even if they only want to check, say, the sales network or their own network. So we want to reduce that broadcast traffic. This is all about reducing the broadcast traffic without having to set up more and more routers, because we know a router only has anywhere from 2, 4, maybe 6, but not a huge amount of fast Ethernet ports for us to plug devices into. So we don't want to be doing a lot of device separation via routers, because as we know, routers, very expensive, switches not as expensive. So if we want to plug devices into a router, we're going to need to hook it up to a switch anyway. So why can't we see if there's a way to separate the networks based on just the switches? Okay. We'll go on to the next slide here. So the benefits of VLAN, as I said, cost reduction is a big one. Cost savings result from the reduced need of expensive network upgrades. So we don't need those as many intense routers, quite sense. Security, like I was saying, separating groups with sensitive data from other groups. So separating HR from IT from sales can help us keep that data traffic completely separate. So there's let's say much less of a risk of overlap. We can get better performance, and this is especially the case when we're looking at reducing the broadcast domains. If we can cut the amount of ARP traffic in half, or any other broadcast traffic in half, or in thirds or quarters, then we can greatly reduce the amount of traffic in each section of the network, which will allow that section of the network to perform better. Not to mention, it will change how the buffers on the different switches and intermediary devices are handling it. Okay, so that's all about reducing the broadcast domains, and then improved IT staff efficiency. So when you're working as a tech or in network administration, if you can easily identify certain sections and they're on their own network, you can do network configurations on just that, section, and it's a little bit easier for you. You know exactly which ports are assigned to students, and you know exactly what their network address is, and you don't have to worry about overlap on network traffic. So you can keep guest traffic. So like here you can see, you can keep guest traffic on its own virtual network, and if there's issues with it, you can shut it down without affecting the ability of your actual students or faculty or your sales staff or your HR team to be able to do their jobs, which is crucial. The whole point of IT tech and network admin is that everyone can do their jobs effectively and efficiently, and you're not causing them problems and your network's not causing them problems. Simpler project and application management. This is talking about businesses that have, it could be geographic requirements and it could be some other requirements. So having separate functions makes managing everything a little bit easier. Essentially, every time something's specialized into a certain area, then if there's an issue, we can fix it in just that area. So that could be an e-learning platform. So for example, the U of A has a lot of courses on Moodle. Elk Island has a lot of courses on Moodle through EAPS Moodle. That whole system runs separate from our day-to-day login system, and our day-to-day login system at BevFacey runs separate from the day-to-day login system at Cell, so that if there's an issue on one of these networks, there doesn't have to be an issue on, oh, all of Elk Island goes down. So it can be quite efficient in that way, and it also allows us to still maintain things like print services. Technically, I can log into my account anywhere in Elk Island, and if I happen to be at SAL, I can print to their printers. So these sorts of things are quite useful in terms of allowing us network access. Because I'm a staff member, I have heightened permissions, but because you're students, you don't quite have the same permissions. So it's quite useful. When we're looking at the types of VLANs, we have a normal data VLAN that's configured to carry user-generated traffic. That's your whatever you're sending, your emails, your YouTube channels, your video games, whatever you're doing, it's the data that you're sending. Could be VoIP traffic, could be otherwise. When we talk about a default VLAN, we're talking about where traffic is going to go, where it doesn't match a specific VLAN. Okay, so when we look at a switch's default VLAN, it's the one that's initially set up on the switch. And the default VLAN for any switch in Cisco, so specifically we're looking at the 2960 switches in this course, but when we're looking at the 2960 switches, we are looking at VLAN 1. So when you guys are configuring switches in the past, you have configured interface VLAN 1, and on VLAN 1, you've set up maybe an IP address, and that's been the IP address of the switch. So you can still do that, but you can also set up VLANs. So you have really been working with virtual local area networks. You've just been working with that one default. Okay, so all ports by default are set to VLAN 1. If you're on your switch and you are in global, sorry, let me just open command line. If we enter global configuration, or we don't even need to, so we will show VLAN, gives us all the information. We'll do that trick of just widening the screen a bit so we can see our table. And we can see some information on our VLANs and some types. If we want to get a little bit more detailed, sorry, I just needed to widen the screen a bit more so that you could see that, in fact, if we show VLANs, the default VLAN contains all of the existing fast Ethernet ports, as well as our 2 gigabit ports. Then we have these other 102 to 105 or sort of special default VLANs. We don't work heavily with them in this course. We will be creating our own VLANs in this space, maybe VLAN 10, VLAN 20, that sort of thing. So if you do show VLAN, it'll show you, just to clarify here why mine looks a bit different. If you do show VLAN, it'll give you all of this information. For the purposes of this course, you mostly only need to do show VLAN brief. Show VLAN brief just gives you this main table. As I said, widen the table a bit, otherwise it's going to display your data a bit weird. So it looks like that, widen the table, data shows up normally. Okay, so then we can see where our ports are to. Okay, the native VLAN is the trunking port. Now we haven't really looked at trunking ports, but they're essentially what allow the intermediary devices to connect together. So when we connect, let me see here. When we connect these devices, even though these are on VLAN 10 and these are on VLAN 20 and these are on VLAN 30, obviously they connect to the switch via their own Ethernet cords, which is fine. So on that, we can easily say F011 is VLAN 10, F018 is VLAN 20, and F06 is VLAN 30. But when we connect the switches together, we're not going to connect an Ethernet cable for VLAN 10, for VLAN 20, and for VLAN 30. So essentially, these ones are our branches. And when we connect intermediary devices together, we need a way to set it up to let it know, hey, multiple VLANs are going to travel over this cable. And we call that a trunk. Okay, so I'm just going to jump back to the next slide. So when they're talking about trunk ports, it's the link between two switches to support the transmission of traffic associated with more than one VLAN. Essentially, we put one cable between the two switches, but all of the VLANs on those switches can transmit across that port, assuming we've configured it so. So when we have a native VLAN, the native VLAN allows all untagged traffic. So traffic that necessarily doesn't come from a specific VLAN will get, by default, go onto the native VLAN. So tag traffic, if your trunk says it can specifically handle VLAN 20 and VLAN 10 and VLAN 30, anything from those networks will go on that, and then everything else will go on the native VLAN. So they maintain backward compatibility for untagged traffic. Usually untagged traffic is when you're connecting to older local area networks that aren't configured with the newer information. It can also relate to when we're doing like static default traffic in the same way that we would be sending that traffic to the internet. It kind of just defaults to that space. And a management VLAN would be what the admin team would use to manage the VLAN. So usually it's VLAN 1 is the management VLAN by default as we've been configuring it, where we set up the IP address and everything like that, where we're going to connect. Good practice is to change it in this course. I think quite often they have you change it to VLAN 99, but it's not necessary. Good practice though, because we don't want, essentially if people know that VLAN 1 is our management VLAN, it's obviously the most dangerous VLAN because it's the one that has all the configuration ability. So we don't want to give people information about what the virtual local area network is by leaving it on the obvious VLAN. Okay, so that's why VLAN 1 would be a bad choice for the management VLAN. They're just saying, if everyone's going to try VLAN 1 as your management VLAN and try to maybe hack into that one or get in through that one, then maybe just throw them a curveball and make it a different management port. That being said, Cisco recommends you make it VLAN 99, and if everybody makes it VLAN 99, it's exactly as vulnerable, so there's some questionability about that, but moving on. Okay, so all ports are currently assigned to VLAN 1, no native VLAN is explicitly assigned, and no other VLANs are active. You would see them here. They would show up under the 1, in between the 1 and the 1002. Therefore, the network is designed with the native VLAN the same as the management VLAN. This is considered a security risk. So because default traffic is going over the same VLAN that your management traffic is going over, problematic. So we may want to realize, okay, we need to add in some other ones. One thing to note, VLAN 1 can't be renamed or deleted. Other VLANs can be renamed or deleted. Okay, so voice VLANs. So when we're talking about separating voice traffic, we're talking about voice traffic requires good bandwidth and to ensure voice quality. It needs to have priority over other traffic. We talked about that before. If you're on the phone and you have a couple second delay, it's a lot more annoying than if you're sending an email and it has a couple second delay. And we're usually talking fractions of a second, but still. Ability to be routed around congested areas on the network. So that's essentially saying we want this traffic to go through. It's priority traffic, right? 1.5 or 150 milliseconds, we're looking at a fraction of a second, but realistically, that's the difference in VoIP, whether it's voice or video. It's quite important, and most phones these days in offices, schools, etc., are running over internet traffic. So it's important we prioritize that traffic, especially in large buildings. Okay, so in this case, the VLAN 150 is designed to carry voice traffic, and the students is on VLAN 20, the student computer, so we can see, okay, this is not going to be as prioritized traffic as this. So the switch knows that it should be prioritizing the phone's traffic over the student's traffic. And again, it's not like, well, the phone call gets to go through and until the phone call's over, the student can't send messages. It's just, if a packet's going to be dropped, it should probably be the student's packet because it'll get resent and they'll probably not notice a huge difference. Whereas on a voice call, it would be super obvious. Okay. So this actually leads into the packet tracer who hears the broadcast. Now in this packet tracer, you have the opportunity to look at sending out broadcasts and playing around with who's going to get the broadcast. So there's a couple different VLANs set up. I'll just bring up the image so you can see what it's about. So here we have all of these different devices connected to a single switch, and you can see that they're grouped into 3 groups, VLAN 10, VLAN 20, and VLAN 30. So in order for these devices to talk to each other amongst the networks, we would need some sort of layer 3 device, whether that's a layer 3 switch or a router, because networks can't talk to each other unless the traffic can be routed, and to route traffic, we need a router. So what you're going to do is you're going to play around with this a little bit, and they're going to walk you through some simulation mode, so you'll actually see the packets physically moving, and you're going to see what happens if you send a broadcast from here, or what happens if you send a unicast message from one of these. So go through this packet tracer, and try to understand exactly what's happening and relate it to what we've learned about VLANs so far in terms of separating them, in terms of the difference between layer 2 connections and layer 3 connections, and also in terms of how we're reducing the broadcast traffic. Because remember, this is all about reducing broadcast traffic and making our network a bit more secure and a bit more efficient. So start this packet tracer, work through it, and then go on to the next video.